Hello students, today I'm going to discuss IGCSE Forecast Examination 1 2022 Chemistry paper for theory extended 1. So some of the students they have asked me, teachers, could you please send the answers key for today's exam? So I said that of course after the examinations maybe evening I will be sending you. So thought of explaining the questions answers, and then of course I'm going to attach this answer file and will send through the Google Classroom as well. Okay, so let's get started and let us discuss how we supposed to answer the questions. Let me begin with the first one. For each of the following, give the name of the element from period 2, lithium to neon, which matches the description. Element may be used once, more than once, or not at all. So they're talking about period 2. So in the modern periodic table, while I was dealing with the periodic classifications, I have already told you that the periodic table has been classified into 7 periods and how many groups? 18 groups, right? So this is the second period. Okay, second period's element. So in the second period, what are the elements? You know, lithium until neon. So do you remember what are the elements in this period? So basically, there are lithium, beryllium. Only this group period elements are making. Okay, lithium, beryllium, and next element is boron, carbon, nitrogen, and oxygen, fluorine. After that, last group, neon, right? So these are the element belongs to second period. Okay, so let's see what they asked in the first bit. First bit, an element which is gas at room temperature and pressure. You can see there are few non-metals, and especially you have to find for the gas. So nitrogen is gas, oxygen is gas, fluorine, and of course neon. So you can rate nitrogen or oxygen, fluorine, neon, anything is fine. So let me write here nitrogen. Clear? Second one, an element which form an oxide that is reactant in photosynthesis. Okay, so an element which form an oxide. So which element can form oxide, and that will be used as a reactant in photosynthesis. Do you remember the photosynthesis process, how it's done? When water and carbon dioxide gas used by the plant in presence of sunlight will form the plant food called here glucose, and carbon monoxide will be the byproduct, right? So here you look at it, which can form an oxide and reactant. So of course the carbon here, because carbon form oxides by reacting oxygen, so it's carbon dioxide, right? So answer will be just right, carbon. Carbon will be the right answer we use for the reactants. Next, third one, an element that is the element that is a product of photosynthesis. Here already I have written the equation, so you just answer. Okay, this is the photosynthesis equations I have written. Product side, there is glucose and oxygen. So here find out the element. Which one? Oxygen. So product of photosynthesis is actually oxygen. Oxygen element, right? Okay. Next one. An element that makes up approximately 78% by volume of the air. So what is that 78%? Which gas found And 78, obviously nitrogen, isn't it? So the answer will be nitrogen. So what next? An element which has atom with full outer shell electrons. So basically the last group element, this is neon. Okay, they will be having full outer shell electrons. Neon atomic number is 10, so 2,8. So already 8 electron is filled in this last shell. So you can write outer shell is neon. Okay, so next one, an element which exists as both diamond and graphite. Look at the period 2, lithium, beryllium, boron, carbon, nitrogen. So obviously here carbon is present because in the allotropic form of carbons already I have discussed with you. Okay, diamond is made out of carbon and obviously I mean the graphite as well. So an element which exists as both diamond and graphite is carbon. Because here carbon is the element which is found in diamond and graphite also. Okay, seventh one, an element that react vigorously with cold water. Which element will react vigorously with cold water? Which element? Here look at lithium can react vigorously because first group elements are very reactive and seventh group element also very reactive. So you can write lithium and fluorine, that you know will be the right answer. So you can write lithium. Okay, so make sure if you're writing in words, so write lithium completely like this. Like a lithium, or you can write fluorine also. Fluorine also will be right because lithium is first group element and fluorine is seventh A group element, right? So fluorine also more reactive. Now a soft metallic element which is stored in oil. Soft metallic element. So which is soft metallic element in this period too? Lithium or beryllium or any other element? Obviously the soft one is the first group elements are soft and basically they are reactive, so it has to be stored inside the oil. So here you can write lithium, right? Lithium going to be the right answer. Lithium is first group element, is more reactive, so it will be stored under oil. Now we give the formula of compound that contain first bit only boron and oxygen. So it's very simple that you have to write the formula which only found boron and oxygen. That means we are writing here boron oxide. Okay. So what you write? Very simple. Boron. Okay, and oxygen. Right. So oxide. So boron valence is actually 3, oxygen valence is 2. So that accordingly you have to write it. So it's supposed to be boron 2 and oxygen 3. Right? How do you get? Because boron actually the valence of boron will be 2 and the oxygen valence, sorry, boron valence is supposed to be 3. Oxygen valence is actually 2. So when you crisscross, you'll get oxide that's going to be boron trioxide. So here let me write boron 2, oxygen 3. Okay. Next, only lithium and nitrogen. So lithium element right here. Lithium element, its valence is, what is the valence of lithium? Atomic number is actually 3. So 1, 2, 1. Valence is 1. There's nitrogen. 7, 2, 5. Okay, it has valency is 3. This 3 is required, right? So here write lithium and here you write nitrogen. So valence of lithium is 1, valence of nitrogen is 3, crisscross. So you will get a formula. Okay, lithium 3, nitrogen 1. So you can write just lithium 3 and nitrogen. Okay, no need to write 1, the variable. Okay, Li3N. So basically these are how to write the formula. How to write the formula. Second one, 2A. Is it clear? First, we define the term atomic number. So what is atomic number? Atomic number basically the number of protons in one atom. All right. Basically, number of proton in one atom of element. Okay, very good. So what is nuclear number? Nuclear number means, let's suppose here they have mentioned the element carbon, atomic number 6, its mass number is 12. So this 12 is supposed to be a nuclear number. Nuclear number. So what is nuclear? How do you get the 12? Basically, it is the combination of proton and neutron number, right? So here you define accordingly. So what is nucleon? So it's the number of protons and number of neutron in one atom. Number of proton and number of neutrons in one atom. Yeah. So you can write this. B, the table shows the number of protons, neutrons, and electrons in some atoms or ions. Complete the table. The first line is given as an example. So first line is given particle A, number of proton, number of electron, number of neutrons, and the symbol of the formula here. The formula of the element. Symbol of the element is, you can say. Okay. B12, proton 12, neutrons, and number of neutrons is 12. Then how do you write it? So if basically this first row, look at the first row. This is 6 is the proton number. 12, it is supposed to be a nuclear number. So same as it is, you look at here, proton number supposed to be 12. So which element is having 12 proton? Okay, which one? Magnesium, right? So magnesium will have 12 proton. And its mass number supposed to be 24, or nuclear number 24. So you just write like this. Okay, now third one, particle C. Number of proton is 8 mentioned. The number of electron, number of neutrons. So they have already mentioned here oxygen 2 minus. So number of neutrons you can calculate easily because number of neutron can be calculated. N is equal to A minus Z. A is basically a nuclear number 16. Z is proton number is 8 is given already. So 16 minus 8 is equal to 8. So number of neutrons is 8, right? So now number of electrons. So how do you write? Here already element written number of electron. How do you find? Oxygen 2 minus. That means oxygen gain already 2 extra electrons. So number of electron protons supposed to be same, right? Number of protons and electrons supposed to be same for the element. But here it is a ion. It is oxygen 2 minus ion. That means oxygen has already gained 2 electrons. So 8 plus 2 is equal to how much? 10. So electron number is supposed to be 10. Okay. The D1, proton number 11, electron number 10, and neutron number 13. So what is the symbol of the element? So if proton number 11, then that must be 11th element. 11th element is actually sodium, right? Proton number is 11, and it neutron number that telling it is 13. So how do you get 13? So it's supposed to be 24. Then only if you subtract 24 minus 11 is 13, right? And electron number supposed to be 10. Okay, here what element I have written? Neutral sodium metal. So it has 11 electrons. So but here in the table they mentioned 10 electron. 10 electron, it is actually in the form of ion. Okay, plus 1 ion. This is going to be the right answers. Okay. Question number 3. Gallium is a metallic element in group 3. It has similar properties to aluminum. A. First bit describe the structure and bonding in the metallic elements. You should include the label diagram in your answers. So you have to draw the metallic bond diagrams here. Let's say these are okay. These are positive charge. Okay, here positive ion. Here are the electrons. These electrons actually for C electrons or mobile electrons are surround this is called positive charge ions, and this electron is called C of electrons. Basically, metallic bond is the attraction force between positive ion and the C of electron. This is the diagram for metallic bond. For any metal, you can do the same diagram. Okay. So you can write here the attraction between force between what C of electron or positive ion, right? C of electron positive ion is called metallic bonds. Next, second, explain why metallic elements such as gallium are good conductor of electricity. Why it is good conductor? Easy, because it has free electrons. Because of the mobile electrons are free. Okay, because of mobile electrons. Mobile electron means free electrons. Give the formula of gallium chloride. So again, you have to make the formula. So it's very simple. So gallium is there. Gallium is, what is the valence of gallium? Here write gallium, here write chloride. Okay, valence of gallium is 3, the valency of chlorine is 1. Crisscross. Okay, so you will get it. Which one? Gallium 1 Cl3. So you write just ZaCl3. It's fine. Okay, so gallium 3 chloride. So here gallium 3 valency sulfate. So it is gallium with valence is 3 and sulfate SO4 which valence is actually 2. Crisscross. So the 2 will come to the suffix of gallium. So here the formula will become Za2 and sulfate. Here there are SO4 and we have to write in bracket. Why? Because the 4 also there are multiple number. So 4 and 3, if I just write here suffix, that will like write like a 12. So that is why the 4 must be written here, and then the sulfate should be written under brackets, and there you just write the 3 is supposed to be the suffix of sulfate. So the formula could be Za2SO4 whole thrice. Okay, this will be the formula of gallium 3 sulfate. Okay, it's very simple how to write chemical formula. Already we have discussed. Now, gallium 3 oxide Za2O3 is amphoteric. Amphoteric means both character. Right? Write the chemical equation for the reaction between gallium oxide and nitric, dilute nitric acid to form salt and water. So very simple. Here write gallium oxide Za2 oxygen plus dilute nitric acid. So HNO3 gives rise dilute gallium nitrate 3, gallium valence is 3, right? So it will be multiplied here, plus of course water also will be produced. Balance the chemical equations. So here 2 galliums are there, so here we have to multiply 2, and let us here we have how many nitrogen? There are 3 and total 6. So here we have to multiply 6. So now hydrogen became 6. So right side only 2 hydrogens are there. So we need to multiply 3 over here so that it will become 6 hydrogen. Now all of them are balanced. You look at this, the balanced chemical equations. Now second bit, the reaction between gallium 3 oxide and sodium hydroxide solution from only water and salt containing negative ions Za2O4 to minus. Okay, write the chemical equation for this reaction. So reaction between gallium oxide and sodium hydroxide. Okay. So gallium, this is ZaO3 gallium oxide, react with sodium hydroxide, NaOH. Okay. So what will you get? You will get Na2 Za2 oxygen 4. Okay, this compound oxygen 4 plus water. Balance the chemical equation. Right side there are 2 n, so here multiply 2, and all are actually balanced. So this is the balanced chemical equation for these reactions. The alloy of gallium and other metals elements are often more useful than the metallic element itself. So there's 2 reasons why alloy of galliums are more useful than the metallic element. What is the reason? The reason you can write gallium, they do not corrode easily. It is hard, do not Correct. Okay, this is the answer you can write. They do not uh, oxidize or don't have restraint. Okay, 4. Hydrogen can be manufactured from methane by steam reforming process. This is the chemical equation you can see. The reaction is carried out using nickel catalyst at temperatures between 700 degrees centigrade to 1100 degrees centigrade and the using pressure of one of the atmosphere. Pressure is supposed to be 1 atmosphere. The reaction is endothermic. So forward reaction is endothermic. What is meant by the term catalyst? So catalyst means it is a substance uh, can increase the rate of reaction, right? Substance that speed speed up the rate of reaction, speed up the reaction. Okay, speed up the rate of reaction or reaction is called catalyst without being involved, without being involved. Okay, very good. Next, B, suggest two reason why temperature lower than 700 degrees centigrade is not used. What is the reason? So if you use less than 700 degrees centigrade, so you may get the reaction might be slower. Okay, can be too slow. Okay, so if reaction is too slow, so definitely the yield might be slower. We'll get lower yield, lower yield. Lower yield of the product, or you can say just write less yield. Clear? Next, suggest one advantage of using pressure greater than 1 atmosphere. So what is the one advantage? The reaction rate can increase. Okay, so the reaction can be faster. Okay, or it can increase the rate. You can write faster, it's fine. Okay, the reaction will be faster. Next one is suggest one disadvantage is using pressure greater than 1 atmosphere. One disadvantages you have to write. What is the disadvantages? If you use lower than that, sorry, the pressure is greater than 1 atmosphere, then there might be, less product. Clear? So here you just write it. Production can be too low. So just write lower yielding rate. Lower yield is enough. Okay. Or you can say it is highly expensive. Expensive also you can write. Costly also you can write. Hydrogen can also be manufactured by electrolysis. The electrolyte is concentrated aqueous sodium chloride. The electrodes are inert. The product of electrolysis are hydrogen, chlorine, and sodium hydroxide. Define electrolysis. So very simple. It's basically breakdown of ionic compound. Ionic compound in aqueous, just aqueous or molten state. is called electrolysis. Okay, AQ means aqueous. Fine. Next, second, name the substance that can be used as an inert electrode. So which can be used as an inert electrodes? Basically, we can use carbon or platinum or graphite, right? These are the substances we use as inert electrode. It's an unreactive electrode. So the carbon, platinum, and graphite. Anyone you can write. So third one, write an half equation for the reaction in which hydrogen is produced. So hydrogen gas and this product of electrolysis are hydrogen gas. So hydrogen gas, it will produce at which electrode? So let's say this is beaker, this is two electrode. Okay, it's connected with the battery. Negative side are cathode, positive sides are actually anode. Okay, so hydrogen gas will be produced at the cathode side. How? H plus, it is negative, so H plus will be attracted to the cathode. That means hydrogen plus two hydrogen will gain electron to form hydrogen gas. Okay, this is called ionic half equation of hydrogen gas. So hydrogen gas produced at cathode, what hydrogen plus and will gain electron to form neutral hydrogen gas. Okay, where is hydrogen produced at the electrolytic cell? So it's very simple at cathode or negative electrode also you can say at cathode, because cathode is a negatively charged. So hydrogen is a positive charge and so positive always attract towards negative cathode. Okay, cathode, or you can write negatively electrode. Okay, cathode is fine. Now fifth, describe the test for chlorine. So what is the test for chlorine gas? We use damp blue litmus paper, right? Blue litmus paper. What is the result? It bleaches or loses color. Okay, turns white also. Okay, damp blue litmus paper will bleaches or it turns white. Okay, very good. F, the electrolysis of concentrated aqueous sodium chloride can be represented by the following word equations. The sodium chloride reacts with water to form sodium hydroxide, hydrogen, and chlorine on the other hand. Construct the chemical equation to represent this equation. Do not include state symbol. Here, no need to include the state symbol. Just write the chemical equations. What sodium chloride? NaCl, NaCl plus water, H2O, sodium hydroxide, NaOH, and hydrogen plus hydrogen is H2O, chlorine, Cl2. Balance the chemical equation. 2Na here also, 2 water, here also hydrogen became balanced. So here it's fine now because here two hydrogen, here two, total four, here four. Okay, now it is balanced chemical equation. Okay, it is the balanced chemical equation. Right side four hydrogen, the left side also there are four hydrogen. Now look at it. 2 NaCl plus 2 H2O, 2 NaOH, hydrogen, and chlorine. The straight one use of chlorine. Where chlorine is used? Chlorine can be used for treating the drinking water. Okay, treating the water. drinking water. Okay, because it can kill the germs. So treating the drinking water. Sodium hydroxide uses, it can be used for oven cleaner or soap. Okay, oven cleaner or drain cleaner also we can write. One usage is fine. Next, hydrogen gas. It can be used as a rocket fuel. Rocket fuel, right? These are the uses. One uses each them. Now, question number 5A. Hydrocarbons are compounds which contain hydrogens and carbon. 10 cm³ of gas, carbon, hydrocarbon X and Y are burnt, and 100 cm³ of oxygen, which is an excess oxygen. After cooling to room temperature and pressure, there is 25 cm³ unreacted gases. Okay, 50 cm carbon dioxide and same liquid water. All volumes are measured under the same condition of temperature pressure. What is meant by the excess oxygen? Excess means more than enough to react, right? More than enough to react. Or you can write some oxygen remained, that is excess, or more than enough to react is called excess. What was the volume of oxygen was reacted with hydrocarbon? What is the volume of oxygen? So look at the hydrocarbon, this much of 10 cm³ hydrocarbons burnt. After burnt, 100 cm oxygen, which is an excess oxygen. After cooling room temperature, there was just a 25 cm unreacted gas found. Understand? So how much 20 cm³ unreacted gases and 50 cm of carbon dioxide. That means the initially 100 minus 25, it's going to be 75 cm³. Okay, so what volume of oxygen that reacted in the hydrocarbon? So there might be 75 cm³ of oxygen, because after reaction, what happened? There is 25 cm unreacted oxygen found. Initially 100. So 100 minus 25 is equal to 75. So write here answer 75. Okay, so complete the table below to express the smallest whole number ratio of volume of hydrogen reacted. Okay, and volume of oxygen reacted, the volume of carbon dioxide produced. So basically here, the volume of hydrocarbon reacted. Hydrocarbons, so initially 10 cm of hydrogen gases, hydrocarbons are burnt. Okay, oxygen amount reacted is 75%, right? And then the volume of carbon dioxide produced. How much? 50 centimeter carbon dioxide gas is produced. So right over here the ratio. What could be the ratio? The smallest whole number ratio of the volume you have to write it. So in the smallest ratio, what will you get it here? So 75 is the what was the volume of oxygen that reacted with hydrocarbon? So oxygen is 75. You got it the answer, right? And carbon dioxide is 50%. Okay, so that here we are going to get it. So what you write the answer here? Third beat, 5 third beat. So volume of hydrocarbon reacted. The volume of hydrocarbon reacted is how much? There was 10, 75% and 55%. So if you uh, divide with 5 maybe, okay, 5, 5 and 5. So 5 2 times, 5 so 15 times, 5 10 times. That means that this is the smallest figure we'll get it. Okay, hydrocarbon is 10 centimeter, whereas the oxygen reacted is 75 centimeter and carbon dioxide gas is 50 centimeters. So just I have made into smallest whole number. Okay, so the volume of hydrogen gas reacted, I got it 2. Volume of oxygen is, I got the smallest figure is 15, and this is going to be the 10, right? Did you see here what I get it? 10, 5 divided by, so 10 divided 5 is 2, 75 divided by 5 is 15, so 2, 15, 10. 2, 15, 10 is just right your answer. Okay, now use the answer first third bit to find the mole ratio in the equation below. Complete the equation to reduce the formula of the hydrocarbon. So hydrocarbon here, what hydrocarbon here we got it 2, so just write here 2. And oxygen 15, right? You write 15. And carbon dioxide 10, and water also 10. Okay, then what will be the formula of hydrocarbon? Can you find it here? The formula of hydrocarbon here, 2 times of formula of hydrocarbon will be C5, carbon 5 and hydrogen 10, right? 5 and H10 is a unsaturated hydrocarbon, so it's a pentene. Okay, so here you get it. The formula, the next one is B. Cracking is used to convert long chain alkane into shorter chain alkene and alkane. Okay, so alkenes are unsaturated compounds. Decane is this, can be cracked to give propene and the other compound, other product. First bit, complete the chemical equations. So here this is the hieralkene cracked to form, this is alkene. So that's supposed to be alkane. So 3 carbon and 6 hydrogen is used up with the alkene. So remaining carbon will be out of 10, it will be C7, 7, right? And hydrogen supposed to be how much? 16. This will be the C17, sorry, C7, hydrogen will be 16. This will be the alkane produced. What is meant by the term unsaturated? Unsaturated contain double bond. It contain double bond compound. Double bond. Okay, so third one, describe a test to show the propene is an unsaturated compound. What is the test we use? Do you remember the famous bromination reactions? So we use aqueous, bromine, right? Or bromine water also we can use. Or you can say use bromine liquid water, bromine water. Then what will be the result? The result will be brown to colorless. Brown to colorless. Okay. So if there is a unsaturated hydrocarbon, then bromine liquid will turns, what is that? The original color is brown, so it will turns colorless. So that gives the test for unsaturated compound. See, propene can be polymerized. The only product is polypropene. Polypropene is a polymer. The equation of the polymerization is this: n times of propene gives rise to polypropene. Name type of the polymerization that occur. So it is a condensation polymerization or addition polymerization. This is called addition. Okay, addition polymerization reaction. Well, because here we have alkene group. Condensation polymerization is different. Okay, there condensation polymerization, so we need to have two different functional group to undergo condensation polymerization. So here answer is addition. Reduce the maximum mass of polypropylene that could be produced from 1 kg of propane. So how much? We produce 1 kilogram only with the answer. So already written kgs, so just write 1. Okay, 1 kilogram. Okay, so that third one, give the empirical formula of propane. Empirical formula means a simplified formula. It's the smallest or the most reduced formula. Do you remember what is the empirical formula of glucose? Glucose C6H12O6. While I was teaching about that, we have discussed. So you have to simplify. What is the smallest? So you can divide 6 with both 3 of them. So carbon 1, hydrogen 2, and oxygen 1. CH2O. This is the formula, the empirical formula of glucose. So similarly here, propane. What is the empirical formula of propane? Tell me. Propane is actually H2O. How did you get CH2? Okay, propane formula, do you remember? Propane, ethene, 2 carbon propane, 3 carbon C3H6. This is the formula of propane. This is the molecular formula. Or this is the formula of propane. So you have to write the empirical, means you have to simplify it. So here there are 3 carbon, right? And 6 oxygen. There are how many hydrogen? 6 hydrogen. So what you do? These 3 we can just divide, you simplify it. You can take here 3, divide 3, here also divide 3. 3 times 1. See 1, 3, here also just cut it, you get 2. Okay, that means this is going to the simplified formula. So C1H2. So you can write just CH2. Okay, so similarly, polypropene, it is just a polymer of propene. So you'll get the same answer, right? Here, can you see this is the propene and this is the polypropene. So C3H6, if you simplify, you will get CH2. This is the most reduced formula. This is called polypropene, the right side. So that also will have the same empirical formula CH2. Okay, so here you write same CH2. Okay, answer is CH2 and CH2. 6. Zinc is extracted from an ore called zinc blende, which consists mainly zinc sulfide, Zn(S). First bit. Okay, the zinc sulfide is the ore first converted into zinc oxide. Describe how zinc oxide is made from zinc sulfide. It's very simple. How do you get it? You have to roast in air. Okay, roasting to be done. So here you just write heat in air. Okay, so zinc sulfide to be heated. So here is zinc sulfide to be heated in the air. Okay. Second one, write a chemical equation for the reaction. What is the chemical equations you have to write? Chemical said, and this is the zinc sulfide. You have to heat in presence of oxygen to produce zinc oxide and sulfur dioxide gas will be coming. Okay, balance the chemical equations. So there are three oxygen right side. These are three oxygen right side. So here uh, you can see here two oxygens. Zincs are equal, sulfur also equal. So what you do, yes, you can actually first equal them. Here multiply 2, and here also you just multiply 2, here also multiply 2. Now look at it. There are two zinc reactant side, two zinc product side, two sulfur reactant side, two sulfur product side. Now oxygen is easy to balance. Oxygen reactant side is 2, whereas oxygen is product side is actually 2 plus 4 is 6. So that it will be easy to multiply here. 3. When you multiply 3, it will become 6 oxygen. So now this is the balanced chemical equations. B zinc oxide converted into zinc. Zinc oxide and coke are fed into the furnace. Hot air is blown into the bottom of the furnace. Zinc has melting point of 420 degrees Celsius and boiling point is 907 degrees Celsius. The temperature inside the furnace over 1000 degrees Celsius. Explain how zinc oxide converted into zinc. Your answer should include details how the heat is produced and the equation of all the reactions were described. So you have to write conversion and the chemical equation too. It's going to be 3 marks. Okay, so firstly write heat produced by the carbons or burning in presence of oxygens. So how your zinc oxide is converted to zinc, you have to write it. So mainly what you do, so zinc oxide will react with carbon monoxide to form zinc and carbon dioxide gas. Okay, so it's produced. So first step, actually you have to heat it, right? You have to heat it so that you will get the carbon. So directly if you react with carbon monoxide, that's not the appropriate way to write it. So better you can write in words, and after that you can write in the equations. So you write here. Okay, so carbon will be heated or coke will be heated. Okay, carbon will be heated to produce CO2. Okay, and then again this carbon dioxide react with carbon to produce carbon monoxide. Okay, carbon monoxide, and after that, you have to use this zinc ore. So let's say here now this zinc metal react with carbon monoxide. So with this carbon monoxide to produce zinc metals and carbon dioxide gas. Okay, so in this way you can produce the zinc metal. So here carbon oxide, what we call carbon monoxide also are used as reducing agent so that metal will be extracted. Okay, so in this way you can write. This is also the right way to do it. First you burn the coke or carbon heated to produce carbon dioxide gas. Now this carbon dioxide gas again it will react with carbon. Okay, when it react with carbon, it will produce carbon monoxide. Carbon monoxide. Now the zinc oxide will react with carbon monoxide to produce zinc and carbon dioxide gas. In this way, you can produce what? Zinc metal. Explain why the zinc produced inside the furnace is a gas. Because temperature inside the furnace is above 900 plus, right? Because temperature inside furnace is above how much? 907 degrees Celsius. That is, the boiling point of the sink, right? Above that is in the inside, the boiling point of sink is above 1000 degrees. So why the zinc produced inside the furnace is a gas? Because the temperature inside is actually above 900 degree, 900 plus, right? 907 degrees Celsius. Third one, state the name of the physical changes or conversion of the gases sink into molten zinc. State the name of the physical change. What physical change do you get? This is condensation, right? So it will condense it, a condensation process. Or just write it will condense. This is the changes happen. See, rusting of steel can be prevented by coating steel with layer of zinc. Explain in terms of electron transfer why steel does not rust even if the layer of zinc is scratched, so that steel is exposed to the air and water. Zinc is actually sacrificial metals, right? It can sacrifice for iron. So basically, in terms of electron transfer, we have to explain. The first point is the zinc is actually more reactive than iron. More reactive than iron in the reactivity series, right? And here what happened? Zinc loses electrons because zinc is coated, so zinc will expose to the air, so that zinc will react with oxygen and will protect the iron. So zinc loses electrons. So here iron gains electrons. Right, zinc loses electron, definitely iron gains electrons. Okay, so the electron is shifted to the iron or steel, whatever it is. So therefore, iron does not lose electron. Okay, so don't does not get oxidized. Okay, this answer you can write. Okay, that's all from these questions. And then D, When the sample of steel is added to dilute hydrochloric acid, then the aqueous solution of iron 2 chloride FeCl2 is formed. When the sample of rust is added to the dilute hydrochloric acid, then an aqueous solution of the iron chloride and FeCl2 is formed. First, with aqueous sodium hydroxide is added to a solution of iron 2 chloride and iron 3 chloride. Complete the table showing the observations you would expect to make. Aqueous sodium hydroxide, iron 2 plus chloride solution, iron 3 chloride solution. What happens, basically here, the sodium hydroxide we use NaOH for the test of cation. Okay, so after addition of this NaOH to the the cation containing solutions, if you find green colors, then that's because of the iron 2. Okay, so iron 2 chloride solution will give you the green precipitate. So you can observe green color. So here you can write green precipitate, green PPT, green PPT precipitate. Okay, and then iron chloride solutions. The test for cation, we use NaOH, and if it's deep into the iron chloride solution, it gives red brown precipitate. Okay, red brown precipitate. Now come to the next. Solution of iron 2 chloride and iron 3 chloride were added to the solution of potassium iodide and acidified potassium manganate. The results are shown in the table. So 2 reagent is taken of the potassium iodide solution and acidified potassium manganate solution. Here. So here the iron 2 chloride solutions, potassium iodide solution now change, iron chloride solution turns from colorless to brown. Whereas the acidified potassium manganate solution turns from purple to colorless and no changes in iron 3 chlorides. Okay, so let's see how to answer these questions. What type of substance causes potassium iodide? Okay. What type of substance causes potassium iodide solution to turn from colorless to brown? So remember it. They're talking about the substance. Okay, potassium iodide. So potassium iodide is a reducing agent, right? So what type of substance causes potassium iodide to turns colorless to brown? So it is actually a reducing agent, mild reducing agent, and acidified potassium is actually oxidizing, powerful oxidizing agent. So just let me write it here. Okay, so basically, can you see this question? A solution of iron 2 chloride and iron 3 chlorides were added to the solution of potassium iodide and acidified potassium manganate. The result are shown in the table. So table result here, we have taken 2 reagent. Okay, first one is potassium iodide solution, second one is acidified potassium manganate. Iron 2 chloride solution, when you use potassium iodide solution, no changes. Iron 3 chloride solution turns from colorless to brown. Whereas potassium iodide manganate solutions, the iron 2 chloride solution turns from purple to colorless, whereas no change can be seen in iron 3 chloride solutions. So second bit, what type of substance causes potassium iodide solution to turn from colorless to brown? So basically here This is potassium iodide is a the reducing agent. Reducing agent. Which one? Potassium iodide is a reducing agent, whereas acidified potassium manganate is a oxidizing agent. Oxidizing agent. They're asking what type of substance cause potassium iodide solution to turns. So as potassium iodide is a reducing agent, so what type of substance cause to this reducing agent to turns colorless to brown? So definitely the oxidizing agent will cause the reducing agent to turns colorless to brown, right? So that the answer will be oxidizing agent. Okay, so oxidizing agent means here oxidizing agent will cause potassium iodide solution to turn colorless to brown here. Okay, so this is the first one. The second is what type of substance cause acidified potassium manganate solution to turns from purple to colorless? So we know acidified potassium manganate is an oxidizing agent. So which agent will cause this oxidizing agent to turn purple to colorless? So definitely it's supposed to be reducing agent. Reducing agent. Okay, so oxidizing agent also can oxidant also you can write. Oxidant, reducing agent also you can write. What is the name you can do? Reductant. Okay, so this is the answer. The fourth one, which iron 3 chloride solution causes potassium iodide solution to turns from colorless to brown. So here it clearly mentions iron, it's iron 3 plus. Okay, iron 3 plus is responsible for changing of color from colorless to brown. Which iron here responsible for the solution to change from purple to colorless? So it will be Fe2 plus. It's already mentioned. Okay, so these are the answers you're supposed to write in this way. I think that's all from this paper. Okay, I hope you understand. Thank you so much.